Hello class, welcome to week 1. This is tutorial for Geography 3440, Remote Sensing for Earth Observation. My name is Tarmo Ramel, I'm your course director, and every week I will be bringing you not only lectures, but also these technical training sessions that are part of your labs. They are intended to be viewed through eClass so that you can actually interact with the videos and work through the H5P interactivity components, part of which you will find contributing to your grades. However, let's turn our attention to the computers in front of us, and I'm going to change my view here so that you can see my computer as well. I've taken the liberty of launching Catalyst Professional, or Catalyst Earth Professional, as the PCI Geomatics has recently been rebranded. And when that launches, we see a toolbar that pops up on your screen. And that toolbar allows us to access many different modules or subcomponents of this very powerful image processing remote sensing software package. So let me turn on my little mouse pointer. It makes it a little bit easier for you to see what I'm doing. And just out of convention, when I click my left mouse button, you'll see that the circles surrounding my mouse will turn blue, and if I right-click my mouse button, it will turn this pinkish purple color so that you can follow along with what I'm doing in my tutorials. So, if we look at this toolbar, we notice here the first piece of software that's available to us is called Focus, and this is the one that we are going to spend the most amount of time with during this course. It is what allows us to display and to interact with and manipulate our remote sensing imagery. I'm going to also use a little bit later on in this course OrthoEngine. And OrthoEngine allows us to perform a series of geometric corrections. What those are and what they're used for, not important today, but it's coming shortly. So we will get some activity in this module. Later on in the course, we're going to use the Mosaic tool, and it's a fancy way of stitching together imagery from multiple different locations to create one large image product. Modeler is a graphic computer programming environment, and we're going to do a little bit of work here just because it helps to simplify repetitive workflows. It also allows us to do something and then modify some settings and see what the output is like without having to do this constant click through and potentially lead to making errors and mistakes. Easy is a text-based computer programming or scripting environment that allows us to implement a whole bunch of stuff that we can do in this course. We're not going to do a ton, but there are some things that are really handy, and we're going to get into that module a little bit as well, a little bit later on. Chip Manager, something that we're not using in this course. Similarly, the fly-through creator, something that we're not going to be using in this course. We also don't have the capability to get into synthetic aperture radar work in this class, but the environment that is available to us allows us to do all of these things. And similarly, this last module here, which is HAP, or the Historical Air Photo Processing tool, allows us to do something very similar to what the Mosaic tool and the OrthoEngine tool allow, but specifically for historical aerial photography. Very, very powerful. Things that if you're ever going to continue on in this field, you might find to be of great use to you. However, let's turn our attention to Focus, and if we click on Focus, and I've already launched it because of the way that all of the licensing and everything works while I'm recording and access to Wi-Fi and so on. I can't do it live, so I've already launched it. But if you click on that button, you will get a screen that looks like this. It tells you at the top that it's Focus. We currently have an unnamed project in here, and there are a whole series of different components to this window layout. On the top here, we have the toolbars, and if I quickly zoom into those, we can see them a little bit better. There's a series of icons and buttons, and those buttons allow us to do certain things. They allow us to interact with the data and the environment. Some of the buttons have a little down arrow next to them, and when we actually have data loaded into focus, then if we were to click on these buttons, then there would be submenus that pop down from those. So we're going to look at some of these key tools today, and we're going to be accessing many of them throughout the term. Across the top, we also have a series of menus, and if we put our mouse pointer and click on them, we can see that there's a whole series of things that we can do under the File menu, under the Edit menu, under the View menu, under the Layer menu, the Analysis menu, the Tools menu, and the Help menu. We're going to get to some of these today and many more of them throughout the rest of the course. However, I'd like to bring your attention to this one here, particularly the General Help. When we click on there, it opens up an incredibly powerful help system for Catalyst Earth and allows you to search for topics, but also to then click through and look at subheadings and options to get real help with using the software. So this would be my first line of, I don't know what I'm doing, I'm going to look for some help. And then of course your teaching assistants or myself to help get you along. So keep that in mind, and you'll notice as we work throughout the course that sometimes when you have a toolbox or something open, in the bottom left-hand corner of that toolbox, let me just show you what something like that might look like, although we're not there at the moment. There would be a little blue icon with a question mark next to it. It's a book, and if you click on that, it provides context-specific help for the thing that you currently are working on. So if you're working on a certain tool, that button will take you quickly to the Help menu where you need to be to get information about that tool. So keep that in mind as well. I'm just going to close those down. So rather than looking at a blank screen, which is relatively boring, I'm going to go back to showing you the full screen, but I'm going to load some imagery into focus. So on my drive system, I have tons of satellite imagery, but I've got this one image specifically from Timmins, Ontario. So a town in northern Ontario. There's the tar file, which is the sort of bundling up of all of these files when I downloaded the imagery, but then all of these files here comprise what that satellite image contains. And I've gone through sort of the process of stitching it all together into a format that Catalyst Earth requires, and that's this one file at the bottom. I've named it timmins.oli.pix. .pix is the extension for the proprietary format that PCI uses for their satellite image files. So the really nice thing is that rather than worrying about all of these files for the time being, it's this one file that we can take and we can copy and move around. Notice it's almost 900 megabytes. They're not small, but as we work with this, if I take just this one file and move it, then all of the information comes along with it. So what I'm going to do is I'm going to minimize, I'm going to simply reduce the size of this, and I'm going to simply take that Timmins file, and with my left mouse button click down, I'm going to drag that image onto focus and let go. And notice that it instantly loaded that image into the viewer for us. It doesn't look great, but it's there, and we can now start to interact with this image. So the first thing is, well, what am I looking at? I'm looking at this small geographic area. The first thing I'm going to do is introduce you to these tools that are up here at the top of your screen. I'm just going to zoom in a little bit. You can see this one here, zoom to overview, zoom interactive, zoom in, zoom out, zoom to 1:1 resolution, and named regions. And we're going to take a look at those over the next couple minutes. So if I click on the zoom to overview button, it zooms out so that I can see the entire satellite image in the viewer at one time. That's relatively handy to have. We can use the zoom in buttons, which take us step by step in, or zoom out, take us step by step back out in terms of our zoom. That's okay. but sometimes we want to zoom into a very specific area of our image, and for that the interactive zoom button is much more convenient. So if we select that tool, we can now go over to our image and then drag an area that we want to zoom into, and it'll instantly take us there. I mean, well, that's pretty good, but I want to see a little bit more to the left. I can take the pan tool, and holding down the left mouse button, I can then drag the image so that I get exactly the framing or the view that I want in the scene. Now keep in mind, the entire scene is in focus. Everything that we do will pertain to the scene, but this is what we see. This is the area that we currently have visible to us as we work with the entire image. So zoom to the full area, zooming interactively to some region, zooming in by one step at a time or zooming out, and panning, which allows us to move the image around the screen where we want it. If we click the zoom to 1:1 resolution, it brings us to a zoom which is the highest spatial resolution that we can display without getting pixelated, but we see all of the individual pixels that are in the image, and it's not resampling as we go on. So that's really great, but we might be working in, let's say, 2 or 3 different very specific areas of this image, and we don't always want to zoom out, zoom in, zoom out, zoom in, pan around and try and find them. What we can do is select the area that we're really interested in. Maybe like, we'll pan that down just a little bit over this way. This is the area that I want to come back to on a regular basis. We can then click on the named regions and click the plus sign, and I'm just going to call this lake, and I'm going to apply and click OK. Now I'm going to go back to the full scene. I'm going to choose the other area that I might be really interested in working in. Let's go right in here. This is the city of Timmins. Say, okay, this is the other area that I'm really keen on. I'm going to click on here, hit the plus sign, and I'm going to save that. I'm going to click apply and OK. Now the nice thing is that we've got these extents saved almost like bookmarks, so that we can go back to the named regions. I'm just going to slide it off to the side, and I can click lake, apply. I can click Timmins and apply, and it will simply take me to the area of interest. So if you're doing work in very specific areas, or if you always want the scene to be exactly the same size and level of zoom that you're going to use to sort of create captures for, let's say, creating tutorials or lecture material, this allows you to make sure that every time you get exactly the same thing. So that's a relatively handy tool to have as well. Okay, so far so good. This image doesn't look so great. Well, this is not really the way that I imagine the Earth to look like. Well, what we can do is we can click on the little plus sign, and we can see the red, the green, and the blue color guns. And what we can do is choose which bands of the satellite image we want to map onto each of these. These are things that we're going to talk about at more length as the course goes on, but just to see, when we right-click on this first band, we can choose any of the 7 input bands that will go into that channel. So, well, content's not specified. It means it simply hasn't been named. We don't know exactly what they're called. Well, we can modify those things, but just for the time being, what I'm going to do is say, well, I'm going to make this one band 4, this one band 3, and this one band 2, and I'm going to hit on the contrast enhancement button. It puts it now into what's called true color representation, where I'm showing the red part of the spectrum with the red color gun, the green part of the spectrum with the green color gun, and the blue part of the spectrum with the blue color gun. So it's as if we were in an airplane looking out the window and sort of seeing the landscape with our own eyes. While this is what you might be familiar with right now, This is not a normal way for most of us to observe landscape level remote sensing imagery, because it doesn't really allow us to get at the really exciting information that's in this data set. So just for fun, I'm going to go here and I am going to look at what's called a false color infrared view. Of course, I have to hit the enhance button when I'm done. And this is a much more normal way for us to look at imagery. Clouds, these white areas still look really bright and white. The black areas here are the shadows of those clouds. The red is highly chlorophyll containing green vegetation. These cyan colors tend to be devoid of vegetation, and we can very clearly see the built up and the road features in this data set. It's also possible to use the scroll wheel on your mouse to do very quick zooming in and out. So if you wanted to see, you can sort of see the grid pattern of roads in here. You can see these little sort of parks and green areas within Timmins. I can zoom out. These dark areas are lakes, ponds, rivers, and so on. We get a sense of what's going on very quickly. It's possible also, if we look at this left side here, we have what's called the control pane. If we don't want to see it, we can click on that button. It makes our image bigger. It allows us to interact on the scene very nicely. But sometimes we want the control pane back, so we can click the button and bring it back. So I'm going to zoom in on it so we can see it in slightly more detail. When we do, we see that we have two tabs at the top. We have maps and files. The maps tell us what's currently loaded into the viewer, and when the check mark is on, it means we're showing it. If I click the check mark and turn it off, it turns that layer off. It's also possible, we see this little pencil next to it, if we have multiple images loaded in, when we click on this layer, it puts the pencil beside that layer, which means that we're now able to edit and work with and obtain data from that very specific layer. So if you have 2 or 3 images open, you want to make sure that the pencil is beside the layer that you actually want to work with. If we click on the Files tab, we notice that this Timmins OLI image that I loaded in has a series of raster layers associated with it. It's possible to have vectors and text layers and other things as well, all embedded inside a single PIX file. However, this one simply has rasters, and when we click on it, we see that there are 7 different raster layers associated with this image. These 1, 2, 3, 4, 5, 6, 7 give us the band number. That's the order in which they appear in the file. The 16U tells us that it's 16-bit data and it's unsigned. This is more of a technical way deciding on how that data is represented, and we talk much more about this in the 4th year course when we talk about data compression and optimization and so on. And then the content's not specified. This is simply a text string that tells you something about what's in that file. So content's not specified doesn't really mean much. So it's possible to go in here and click on that and type in something that's much more meaningful. So the cirrus cloud layer. This is the blue band. This is the green band. This is the red band. This is the near infrared band. Shortwave infrared first band. Shortwave infrared second band. So this now is already much more meaningful, so that when we look at any of these individual bands, we know what it is that we're looking at. So when we go back to the map view and we go to right-clicking on what we want to show on the red band, or in the red color gun, we can click on near infrared, red, and green, and have those show up nicely on here so that we know exactly what it is that we're looking at. We can also take this and slide the width of that so that we can maximize the area that we see on our map. This is the basic way of getting sort of around what we're doing. It's possible to go up to File and hit Save Project. keeping in mind that this basically saves a series of pointers to files that are on your computer. So if you move things around, they won't open properly when you go into focus the next time. So you really want to make sure that you save whatever you're doing to your PIX file, and you might use the project to keep things organized and keep everything for a single assignment in one project, but make sure that you create unique copies of everything in a folder on your computer that isn't going to get messed up with any other way. I'm going to go back to the full screen, and we're looking at this data set and say, well, this is great, but what can I get out of here? How do I know what numbers or values are actually being stored? Where is this location? Very key pieces of information, which we can generally get from the bottom of the screen. So this here gives us an easting and northing in UTM coordinates. This is a projected image. And if I were to click anywhere on this image, notice that it leaves a little yellow crosshairs. At that location, we can read the coordinates off the bottom of the screen. If I click somewhere else, let's say in the middle of this little lake or pond, we see that the coordinates have now changed. We also see the red, green, and blue, that is what's shown in the red, green, and blue color gun bands. What are the pixel values at the location where my cursor currently is located? So if I click on here, if I click here, if I click here, if I click here, those values will change based on where I have clicked. Even if I move my mouse away, where that last click was is where these values exist. So if I zoom right in so we can see the individual pixels, if I click on this cell, we can see the red, green, and blue values are quite high, which means it's bright. If I click here where things are a little bit darker, those numbers should all get a little bit smaller. Higher numbers, lower numbers. It simply tells you something about the relative brightness of that cell. It's also possible to click on this numeric values button, which for the band that's currently shown in the red, the green, and the blue color guns, see the center pixel here is outlined. Where that crosshairs is in this pixel, it tells us that the value stored in the red band in the file is currently 18,500. The value for what is currently shown in the green color gun, which is actually the red band, is 8,206. And for the band that's shown in the blue color gun here, which is actually the green spectral band, the value is 8,845. So these are the actual values that are in the file, and this central cell is where we've clicked, but everything else shows us what the neighboring values are around that location. So if I were to click here, we see that currently this near infrared spectral band, which is shown in red, has a value of 20,468. The pixel directly to the south of it has a value of 17,936. So if I click on here, that value now shows up in the center. So it gives you a spatial area of values around your current cursor. It's also possible to look at the enhanced values. We'll look at what this means, but there's a distinction. Raw values are what are in the files, and enhanced data simply changes how it's being shown to you on the screen, keeping in mind that everything that we do to this data, any calculations that we do, is always done on the raw data. The enhanced data is simply how it's being shown to us. So if I went in and I changed the enhancement technique, all of these values change, but the values in the file, the original raw values, don't change at all. So something to keep in mind. The difference between raw and enhanced, something that we get to a little bit later in the course as well. It's possible, I'm going to zoom out a little bit, to change the brightness, overall brightness of the scene. Every time I click on this little thing, it gets a little bit brighter. I can decrease the brightness. And if I feel like I've messed something up, I can always go back to resetting it to the default values. I can also do the same with contrast. So I can increase the contrast by clicking on that. I can decrease the contrast. And I can always go back to resetting to the basic default values. And say, oh, what was happening over in that lake region? Well, we can still use our bookmarks and go back to seeing what was at that same extent that we were interested in before. I'm going to zoom in on this image so we can get to a single pixel level, somewhere where we can see some detail. I'm going to zoom right into a single pixel here. We can use the measure tool. We can measure lines, polygons, rectangles, ellipses. We can change the units of measure for area, for distance, and so on. First, I'm going to simply take the line measurement tool, and I'm going to click approximately on the corner of this pixel, and I'm going to click approximately on the corner over here. And if we look down at the bottom of our screen here, we can see that the total length of the segment that we drew is about 30 meters. So we know that this is now 30-meter spatial resolution data. It's a very quick way to get an idea of what is the spatial resolution of this data set. We can hit escape to get out of that tool. We can also measure the area of that cell. Obviously, if you know that one side is 30 meters, then you square 30 meters, you should get 900 square meters. But let's just verify that. And if we look back in the bottom corner of the screen down there, and we see that it is basically 900 square meters, because I'm not drawing it perfectly, because I'm estimating it on the screen. And if I zoomed really far in, I'd notice that I wasn't exactly on the lines of the pixel, but it gives you a really good idea of what the spatial resolution is and what the area of an individual pixel might be. If we have 2 pixels, that area is 1800 square meters, and so on. So no surprises. We have a spatial resolution. We know the area that a pixel represents. We can count how many pixels gives us what kind of an area. This is all sort of fundamental to the structure of your image. It's also possible to use the information tool, click on a pixel, and it gives you the near infrared, red and green values, the raw and the enhanced values that are currently being shown. So again, relatively useful pieces of equipment. We have other tools here that we're going to spend more time with later in the course, but if we go to the layer menu item, we'll come to things that we tend to use more often than not. So let's zoom in a little bit. Under layer, we're going to look at things like histograms. We're going to be able to look at things like statistical scatter plots, hyperspectral plot views, and let's take a look at what some of those things look like right now. So if I turn that measuring tool off just so that it's not following me around, if we go to layer and we click on histograms, we can see that there's a histogram that shows us what the red and the green and the blue color gun bands are currently showing us. So if we choose one of these, we can see that it's showing us the values in the current area. Well, that's not good. Let's take a look at the entire raster. And we can see that we have some dark values, then a whole bunch of these intermediate values, and very few very bright pixel values. We get some basic image statistics, mode, median, standard deviation, maximum value, minimum value, mean value, the number of pixels. It tells you something about the distribution of values on this band. If we go back, we can do the same thing for the green. We want to make it for the entire raster. We can see what the distribution of values are for the green, which is actually the red spectral band, but what's being shown in the green color gun. And they're color coded to help you remember what band is being shown in which color gun. So this is something that we're going to come back to many times throughout the course as well. We can look at the scatter plot, and we can choose a band to show on the y-axis and a band on the x-axis. So currently it's showing the band 5 on the x-axis, and it's showing band 4 on the y-axis. And the brighter these colors, it means that more times that combination of values in the file corresponds between the two different layers. So we can change the bands here that we're looking at, and the graph will change. We're going to get to more of this stuff as we get into classification as well, and you can always make the screen a little bit bigger so we can see it better. Again, a whole series of options, tools. Notice that there's the help button at the bottom when you're trying to figure out what to get done. And if we go to hyperspectral spectra plot, what we have, if we were to click on a pixel, we would have the band 1, 2, 3, 4, 5, 6, and 7 values plotted as a graph. Why it puts the 0.5 increments along here, I can't fathom. It doesn't make sense to me. But we have here a brightness, and this shape of this curve tells me very quickly that this is chlorophyll containing green vegetation. We're going to learn about why a little bit later in the course. But looking at what's called the spectral signature, or how do all of the values in the various bands behave when we look at, sort of imagine drilling down through that image. This gives us a lot of information from many different dimensions, many different spectral bands, what's happening in this given pixel. So if I just zoom out and I look at something like water, I look at something like vegetation, I look at something like a cloud, which seems to be really, really bright. These are the kinds of things that sort of really stand out. And if I zoom in here, let's say to one of these areas, it's a little bit more, right? Each of these areas will look different. But if I click around in here, notice that all of the curves look roughly the same. This idea tells us that these pixels are spectrally similar. Maybe they mean that they contain the same land cover type on the ground. So these kinds of concepts and ideas are things that we're going to explore in this course. So lots of really great and interesting things here to take a look at. I really do sort of hope that you take some time to take the demo imagery and open it up and explore. This doesn't sort of always click instantaneously. It takes time to play around with the data, to get a feel for what's here, to learn how to navigate your imagery, learn how to pan around, zoom, and sort of look at the different components of your data set. And then we're going to start building on top of that with all the really interesting things that we can do with remote sensing. But it does take a little bit of time, so do sort of just explore. And you're not going to mess anything up. You're not going to destroy your data sets. And if you do, we just simply recopy the original data back and we continue from where we left off. But each time you have to work on an assignment, you're going to get a new clean data set anyway. So you can use the demo data and just explore and get a sense of what Catalyst Earth and what Focus starts to provide for you. We're going to take you step by step through the rest of this course. But until next week, have some fun exploring. Talk to you later.